A is the exponential, so that would be y equals e to the x. B is the square root, and C is the reciprocal. So there are the answers to that part of the quiz. The first one is the exponential, the second one's the square root, and the bottom one is the reciprocal.
Good question. Will the quiz tomorrow be just like this?
It'll be formatted the same.
Format.
Yes. But obviously I'm going to have different curves in different places.
Does the reciprocal have a negative or does it not?
It does not have a negative. It does not. And a couple people did that, so I'm not sure.
In the book,
In the book, I had 2 dashes.
it's like, yeah, it's 2 dashes.
Let me look at that and see.
Yeah,
There
that's
is
what I
no negative on that, but a couple people did stick it in, and I was curious as to how that happened.
On which one?
Number C.
The reciprocal.
Oh, somehow that fraction bar has a little gap in it, doesn't it?
Yeah.
Yeah, no, it's 1 equals y over x, or y equals 1 over x is the reciprocal function. Okay, and then, which functions did we not use? We went through part 1, part 2, part 3, that's 6 functions we used up. Which ones did we not use? Well, we certainly didn't use the cosine.
Reciprocal.
No, we did use the reciprocal. We didn't use the cosine, we didn't use the identity, and we didn't use the natural log. So these are the 3 that we didn't use, and you could draw them. These are the equations. You could name them or draw them, whatever worked for you. Now, does anybody have a question about something you missed on this?
Can you draw the cosine one more time?
We'll see. We can have one.
Can you draw the cosine one more time?
The cosine curve, when we draw the cosine, it has the same waves as the sine, but it starts on the axis up here.
Oh, okay.
Yeah.
All right? Okay, so let's put that away then. And let's get out our extra practice sheet. I did most of this for you in class. I can't remember exactly. So of the ones that I didn't do, did anybody have a question about one of our homework problems last night? Which one?
J.
J. J is the cubing function, which will, if I don't look at just the straight cubing function, that would look like this, right? This is just the regular cubing function.
I just wasn't sure if I did it right. So it's like 2
Okay.
right.
Is this the cubing function? Okay. Now we have to decide, what does that do?
2 to the right.
That moves it 2 to the right, because that 2 is attached to the x. It is not this problem. What would this problem do? Move you 2 down. This is what we have. It's going to go 2 right. So you're going to pick this picture up. Pretend you can just lift it off the page, and you're going to move it 2 units to the right. So it's going to look like that.
Bless you.
Okay? Anything else from the extra practice worksheet last night? Maya?
So when you have like the exponents, do you just ignore them? Is it just
Which one you looking at?
like one?
On problem D? No, you don't. Well, you can't ignore the exponent, Maya, because this tells me that it's a squaring function. This tells me this is a squaring function, so that tells me my shape. Now, when it comes to moving it how many units, then I don't worry about the exponent. But that tells me this is a squared, just like this one told me it was a cube. So the exponent gives me the shape of the picture. but it doesn't impact how far you're moving, right? Is that what your question was? Yeah. Yeah.
Okay, I know you did this yesterday, but can you just for me, put your brown, you do G one more time.
No, but since I already did it, but one of them I didn't do yesterday. Which was the one which?
E.
I'll do E for you, John.
That helps. Thank you.
All right, so we'll do E. Bless you. Okay, so here we go. Ron, what shape is that top equation?
Square, should that be a U?
It's gonna be a parabola, right? So I'm gonna go ahead and graph my parabola. There's my parabola. Now that's the whole parabola. Okay? But I don't want the whole parabola. I want only a piece of it, right? And when I say I want a piece, by the way, it's this piece, right? Not this piece. Somebody made that mistake on their quiz. I don't want that piece, I want this piece. I want a piece of it. I mean, I like this too, but not in math. So I want a piece of this, okay? So y equals x squared if x is less than or equal to 1. Jabron, I'm doing this for you and you're not even paying attention.
I was paying attention, I was laughing.
Okay. So where x is 1 is right here. So I'm going to go up till I hit my curve, and I'm going to put a solid dot there on the curve. That dot is solid because of the or equal to in the top line of the problem. Then, Jabron, I decide which piece I want. Do I want the piece to the left of the dot, or do I want the piece to the right of the dot?
To the left.
To the left. So I'm going to erase the piece to the right because I don't want that piece. Now, what's my second equation? Y equals x plus 3. What shape is that?
That's going to be line.
A line. It with a y-intercept of 3 and a slope of 1. So up 1 over 1. So here's the whole line. That's the whole line. But again, I don't want the whole line. I want a piece of it starting where x is 1. And this time that's going to be an open dot. And then I have to decide, okay, do I want the part of the line to the left or to the right? Look at that. What's that tell you? To the right, greater than. So I want that part of the line. So I erase this part. When you draw your piecewise functions, you should never have a piece on top of another piece. In other words, if you got confused and you kept this piece of the line right here, you kept this, you would know automatically that's wrong because it doesn't pass the vertical line test. You can't have a piece of a function on top of another piece. So double check when you're done, when you think you're done, look at it and say, hey, nothing's on top of itself, right? Because you can't have that.
You said you're fine with us doing the teacher.
Absolutely. I'm interested in that picture right there, so how you get that is completely up to you. As long as you're not cheating. Will? I is a natural logarithm function. Now, the normal natural logarithm function looks like this. That's the normal one. What's happening here? What are we doing? We're moving that 2 units to the left. So I'm going to pick this picture up, and I'm going to back it up 2 units. Now, see how the asymptote is approaching the axis here, or the curve? See how the curve is approaching the axis? That's going to get backed up. So now I'm going to have an asymptote back here, 2 units back, because everything's getting moved back. So that asymptote right there is getting shifted back. So now it's gonna look like this. You okay with that? Now, do you understand that you can't do most of the problems on this page if you don't know your BFFs?
Oh, yeah.
Because you can't graph that if you don't know what to start with. That's why we've got to get these things straight in our heads. And some of you have done great, like I said. Some of you, I'm so tickled. But some of you, you need a kick in the butt. And I will do it.
You definitely don't recommend.
All right, get your note sheets out. Here we go. Got some learning to do today. Tomorrow, BFF quiz number 2. Formatted just like BFF quiz number 1. All right, here we go. Some of this you're going to find so easy, and I think all of it is review. So here we go. Question number 1. We're going to add f of x and g of x together. Boys and girls, this is very common sense. Will Aylick, pay attention so you can get another perfect paper.
What problem are we on?
We are on note sheet number 10, backside. Note sheet number 10, backside.
So we're the 1.4.
Yes, we're starting 1.4. Okay, chatty table here. Note sheet number 10, backside. Here we go. Problem number 1 says add f and g. Kids, f is x plus 2, g is x squared. Just add them together. Add them together. There's f. There's g. The problem says add them together. Then put it in descending order. Oh, there's a word. Do you know what descending order means?
What's the grade?
That's right. Biggest to littlest. So the biggest power goes first and on down the line. And you're done. Stop. Don't solve. Don't factor. Don't do anything freakish. Stop. It's that easy. Let's look at the next one. 2f of x. Do not make this hard. 2f of x means take 2 times f of x. This is f of x. Take 2 times it. So what's my answer? 2x plus 4. Don't do anything to it. Don't solve it. It's not an equation. Don't put a 0 in there. It's nothing. It's done. All right, what do you think we're going to do in the next one? We're just going to take g, which is x squared, and we're going to subtract h. Now, notice I put my h in parentheses. That's important because when you're subtracting it, you got to remember to subtract both terms, right? So that's going to become x squared plus 2x minus 5. Perfect. Very good. What do you think? Let's see, I need to keep track of these answers. So let's see, this was A, this was B, this was C. Okay, what do you think's going on in D?
Multiply.
I'm going to take my F and G and I'm going to multiply them.
Is it 4?
So F is x plus 2. And what's G? X squared. So we're not going to have to FOIL this time. I would have to FOIL if I were multiplying these two. But this is just going to be a distributed, isn't it? So what am I going to get?
X to x cubed plus 2x squared.
You're exactly right. Very, very good. And then E. What do you think's going on in E?
Then you have to
Divide.
I'm just going to divide them. So f of x is x plus 2. And g of x is x squared. And there's the answer. That's it.
2 over x.
No. You cannot cancel unless you got your triangle going, remember?
I thought it'd be, okay.
Yep.
I see where he's going with that though. If there's more X's on the bottom, how come you don't show them?
Right.
Because you don't have an X here to take it out of. If you had X squared plus X over X cubed, then you could cancel an X out. This is just like those other problems we did. If there's a plus sign in your problem or minus sign, you have to cancel out of every piece. You can't just pick and choose. It's gotta come out of everything. No, not unless we had it in all three spots. No, we would never do that. You never just reduce a part of it, ever. You gotta believe me, Maya, I am not lying to you.
Wait, so you're
I
saying?
know you're not. I just feel like, I just remember this very clearly. I just don't know what you said. I'll find it though.
What?
I'll let you know.
Okay, thank you.
Never.
Next question, what is the domain of all these things? That's why I wanted to keep my answers. Here's A. What's the domain of this problem?
What?
Domain.
No idea.
Isn't
Two?
it?
Who said that?
Olivia.
Olivia Willis, I love you. All real numbers. You guys, back up.
Bonus.
Domain. Domain. What are the issues we have with domain? Denominator can't be 0, and whatever's under the radical has to be bigger than or equal to 0, right? Look at that problem in the box. A.
It's good.
Does it have a denominator? Does it have a radical?
No.
Let me say it one more time. No radical, no denominator, no problem. All real numbers. Every time. Got it? All right, let's look at number 2, or B.
All real numbers.
All real numbers. No radical, no denominator. All real numbers.
Ron has C,
C, Jubran.
all real numbers.
All real numbers. No radical, no denominator.
We'll go 2 for 2,
How about D?
all real numbers.
All real numbers. No radical, no
Like
denominator.
Kobe in the 4th, I'm gonna go for 4.
All right, what's this one?
Now, this is a little different because it has a
It
denominator.
does.
So then you have to, the domain, you have to, hold on now. Hold on now. That's killing me on my face. Gotta get through, here we go.
Said the last one.
Don't you have to reduce, but that's how you get Y, to get X. Oh man, I might have made a mistake. Set it not equal to 0. Set X squared not equal to
The
0.
denominator cannot equal 0, which means x can't be 0. So your domain for the last problem, E, is x can't be 0, because it has a fraction, right? Now, G starts something different. G starts what we call composition. Please note, shh, this can be confusing for people, so I'd like it quiet so you can pay attention. Please note that even though the F and the G are written right next to each other, this is not a multiplication problem. This is read F of G of 2. That's how you read that. If you were going to say that out loud, you would say F of G of 2. It's not multiplication. Sometimes that problem is written with the fog notation. Does that look familiar to you? Have you seen that before?
Yes.
That's a little tiny open circle. Like if you wrote a degree, like 32 degrees,
It's on H.
it looks like a little degree mark. It's a little open circle.
It's on letter H.
These mean the same thing.
Yeah, letter H is the font.
Oh. Oh, yeah, it does. Thank you. Thank you. So actually, G and H are the same problem.
Yep.
They are exactly the same problem, just written different ways. So who Who remembers how to do this problem? What do we do? Kieran?
You gotta put, like, okay, so you put the 2 in for the g, like, for the g function, which is x squared, so you put 2 in for x.
Okay, I'm writing down my functions real quick. Okay, so you say put the 2 into my g function.
Yeah.
And you're exactly right. So I'm gonna put 2 into g, so I'm gonna find g of 2. And what would g of 2 be? 4. All right, so then what do I do?
Then you put that into the f function.
I take the 4 and put it into my f function. So in other words, let's get the answer. So f of 4 would be 6. So the answer to the question is 6. It's a 2-step problem. F of g of 2. So first we find g of 2, which is exactly what Karen said to do. And then once we get it, we take that and plug it into f. Does everybody see we're kind of working backwards this time? We're starting with the letter closest to the number. Problem H is exactly the same thing. The answer is 6. It's just a different way of writing the problem, but it means exactly the same thing. All right, I is the same kind of problem, but it uses different functions. So here we go. Oh no, it's the same functions. Oh, what's different about I, you guys? It looks like the same problem, does it, or not?
Yeah, but it's
Flip.
It's in the other order, which means that we're going to start, Kaylin, by putting 2 into f. So what's f of 2? 4. And then what do I do with the 4? Put it into g, and what's g of 4?
16.
Oh my gosh, I got a totally different answer, didn't I?
Totally.
Because you did it in a totally different order. It makes a difference. H of f of -1.
-1 plus 2.
So I'm going to start by finding f of -1. So that would be what? What's f of -1? 1. And then I'll take the 1 and plug it into h. Where's h? What's h of 1? H is -2x plus 5. So what's h of 1? 3. And that's your answer. Oh my gosh, look at K.
No idea what
Oh, this is a big.
This is a big one, Katie says. Now, where do you think we start? By putting 1 into H. Okay, so here's H.
Oh, that makes sense.
Let's put 1 into it, and what do we get? 3. Step 1 complete. Now what am I going to do with the 3? Put it into G.
9.
G of 1 is
9.
9. And then what am I going to do with the 9?
11.
Put it into F. And the answer to the question is, I heard it out there, 11. Okay? Now L. Uh-oh. What is different about L? They didn't give me a number, they gave me a letter. But I am not fearful.
You're not fear of this Ford is here.
That's right. I'm woman, hear me roar. All right, G of X. what is g of x? Well, they tell you g of x is x squared. So this is x squared. So what's the problem asking me to find? This is, think of this as x squared. So what's the problem asking me to find? F of x squared. Now remember, when you find f of anything, you take out the x and plug in what you want. So if I want f of x squared, I'm going to take out the x and plug in x squared. So that would simply be x squared plus 2. Let's try another one. Luckily we have another one. H of f of x. Now what do I start with? What do I start with? F of x. So, Miss Fox, f of x, according to the problem, is x plus 2. I don't have to do anything. It says, what's f of x? F of x is x plus 2. Okay?
We just gonna ignore that?
Now, this is x plus 2. This is x plus 2. F of x is x plus 2. So now the problem is saying find h of x plus 2. This is x plus 2. So it says find h of x plus 2. Okay? So I go up to my h function, and every time I see an x, I'm going to plug in h plus 2. So I'm going to have negative 2 x plus 2 plus 5. Right? And then I'm going to distribute and collect like terms. So there is my answer. Now, I'm going to put a couple up here, and at your tables, I want you to sort through them, okay?
Okay.
All right, so let's get some different functions. So I want everybody focused and working on these. I'm going to give you 3 problems to practice on. So if you're confused, now is your time to get it straightened out. Let's use function C is 2x minus 1. Function H is 3x squared. And function S is negative x plus 1. Alrighty, dighty. Here are your 3 problems. I want you working on these together. Here we go. Let's find C of H of S of 2. Let's find C of H of X. And let's find S of C of X. All right, here we go. Let's go. At your table, let's try these 3 problems.
Each month I need to
Stop it.
She's going at it. Chill. These are her favorite. I love 2 for So you start with the S.
I did all.
I messed that up last time.
I mean,
Yeah, let's go. Let's get these done.
did you get a negative 3 for that? Because negative 1 squared is 1.
So, start from, yeah, the S is negative X. So negative 3, come on. Negative 2 plus 1.
Because
There's
Then
absolutely
you
no
plug
way.
negative 2
there's
plus
no
1,
way it's going
which is
to
8. Yeah, but
You
what's
get
negative 2 plus 1? What's negative 2
You
plus
get
1?
negative 2 plus 1, which you get
So negative 1, so then you take that negative 1.
Negative 1 squared.
You plug that into the H.
no, negative 1 squared is 1.
Negative 1 squared. Yeah. So
Negative
it'd
1
be 3
squared.
times negative 1 is 3. So that's
Square, you can, yeah.
3 squared, which is
calculator.
Okay.
It's 3 squared, or is it just 3?
How about these?
It's not really.
Wait a second, we only got one.
When you fill it in,
Two.
like the 2x, do you fill it in like this?
Mhm.
Oh, okay. See, I was like putting 2 parentheses and doing 2 minus 1, and then we'll square that. No, you do 2 times negative 1.
Take out the x and go 2 in place of it, that's all you do.
Two, and then
Okay.
5.
Katie Thomas.
I don't know.
You got this one done, Katie?
Yes. It's 3. The first one's
You got problem 1 done? All right, let's walk through it, Katie. You can do it. I have confidence.
the S's.
Okay, here we go. Where do we start? Katie Roth, quit giving her answers. So Katie Thomas, where do we start? Yep, so what value am I going to plug in? 2 is going to go into S. Okay, so what would S of 2 be? Now be careful. I'm taking out the X and I'm putting in 2. So it would be negative 2. Let me just not put the parentheses. It would be negative 2 plus 1, which is? Perfect. Step 1 complete. Now, what are you going to do with that negative 1? Put it into H. So H of negative 1. So all we do is take out the X and put in negative 1. So we'll have 3 times negative 1 squared. No. What's negative 1 squared? 1 times 3. The 3 isn't getting squared, the 1's getting squared. So that answers 3. Now what are we going to do with the 3? Put it into C. So C of 3 would be 2 times 3 minus 1, which is 5. That's the answer to the question. How many tables got 5? Bryce Akers, you awake back there? Bryce, get up. You know it frosts me when your head's down. Get it up. Get up.
Frost. You using today?
What about the?
Urban Dictionary last night?
Yeah. Okay, here we go. These are the more confusing ones, at least for me. They have letters in them. So I start right here. What is h of x, you guys? Don't make this hard. They tell you.
3x squared.
H of x is 3x squared. This right here, kids, is 3x squared. So we're finding C of 3x squared. Do you see that? So you go to your C function, and every time you see an x, you plug in 3x squared. So 2 times 3x squared minus 1.
6x squared minus 1.
Perfect. How many tables got that? Okay, good. Very good.
I didn't get to the third one. Can we get a little 1 minute power break for that?
No, we're going to go through it together because we have one more topic to talk about. What do I start with here? The C function. So I start with C of x, which they tell me is 2x minus 1.
And then you plug that.
That's right here, kids. This is 2x minus 1. So the problem is saying find S of 2x minus 1.
Quick question, what is this exactly called? What's
Composition of functions.
composition of
Composition of functions.
I didn't know what.
So now I go to my S function, and every time I see an X, I put this in. So I'll have negative 2x minus 1 plus 1,
Yep.
which is negative 2x, watch it, plus 1 plus 1, negative 2x plus 2. How many tables got that one? Good. You guys are composition monsters. Good.
If I could have done this last year, I would have.
Now, we have one more topic to talk about, and that's in number 2, the implicit functions. Now,
Let's get this over with.
this is so simple, but it's important in calculus. You're going to need to know how to find implicit functions. We're getting you ready for calculus, Karen, so stop it. All right, so here we go. All I want you to do, very simply, to find the implicit functions, is get y by itself.
Oh, I
So
know.
make a little note over to the side. Get y, Tyler Decker, get y by itself. I know she's cuter than me, but I want you looking at me, okay?
Ooh, Kayla, you bad, girl.
Get y by itself, all right? So y squared equals 4 minus x squared. What did I do? Subtracted the x squared.
Yeah.
Maddie, you taking notes on that iPad or you emailing somebody? Y squared equals 4 minus x squared. Everybody with me so far? Last step, and we're done. Last step,
Square root.
take the square root of both sides.
Oh, yeah.
Do not forget the plus or minus. Simply take the square root of both sides. Now, do not attempt to do anything with this. Do not say 2 minus x. You will be wrong.
Wait, wouldn't
That does not simplify.
Wait, quick question.
And no, it does not simplify.
No, that's not my question. Since you're taking the square root, wouldn't that just be 4 minus x, not 4 minus x squared?
No, because you're taking the square root of the whole quantity. You can't change anything.
Oh,
in there.
got you. Okay.
Anything.
Right. Just no
Now.
effort. Got you.
When I look at the direction, did you notice it said implicit functions? Are there more than one answer here?
I hope not.
Yes.
Oh, no.
There's the positive root and the negative root. If you want to write them separately, you can, but it's perfectly okay with me to leave them this way.
So you put the X on the end of the problem, not the, like, always like that. on
You
that
have to
side.
have y by itself, Will.
Okay.
So that means everything else is moved over. It doesn't, the order here doesn't matter.
Okay.
If you square root it though, wouldn't x squared cancel out?
No. Let me say this one more time now, everybody listening. This does not simplify.
Nope.
Let me show you an example. Would everybody agree that 3 squared plus 4 squared equals 5 squared? This is 9, this is 16, this is 25. That's a true statement, right? When I take the square root of both sides, if you try to do what you're trying to do, which is illegal, you cannot simplify this. But if you try to do it, look what happens.
That doesn't
It doesn't equal. And you know why it doesn't equal? Because you can't do this. When you put a plus sign in there, you don't simplify. You can't. Okay, or a minus. All right, we got to get through a couple more. Here we go.
She said, I'm saying like you were very aggressive when you slashed through that problem.
Implicit functions. I need to get y by itself. So what's step 1? So y squared equals 8 minus 2x. Get rid of that 2x. What's step 2?
Square.
Y equals plus or minus the square root of 8 minus 2x.
That's it.
Done. Done. It is easy. It's all easy.
So if this said solves versus implicit functions,
That's a whole different thing. We're not talking about it.
oh, gotcha. All right then. All right.
All right, here we go. Try this one on your own real quick. I don't know how much time we have, but I have a feeling we're running out.
I've already done that.
Find the implicit functions. Katie, you got it done?
It's 6 and
Okay.
16.
Step 1 then, Katie, since you already did it. Y squared equals?
Y squared equals x. Oh, I was gonna say, are we doing the fourth one or this one?
We're doing C. This is C.
It's
It's a 6, not
6.
16.
Oh, thank you.
Oh, I was gonna say I subtracted 3x squared to the other side, and then I got y squared equals square root 6 minus 3x squared. And then I did y equals plus or minus 6 minus.
Okay, boys and girls, your homework's posted, let's get it done, quiz tomorrow.
Nothing knows.
Don't act like you don't know that, I told you that already.
Okay, so I thought it was over this.
Have a good day, see you tomorrow.
I'm gonna talk to you soon. I know.
This one, is there any way I could get points for lunch? I just, yeah. When you said coming early on Thursday.
A bunch of points tomorrow.
Okay. Because I actually am ready for this one. And I have that covered. I should have worn it with me.
I know.
I think my car. Can we get to it and then I'll do it down?
Have a good day, peeps.
Bye.
Oh, shoot. Oh, that's on video still. Uh-oh, I think somebody left a lunch.